we have to find how many integers are there between pair of numbers. We have numbers from 1 to 30. First, what it means integers. An integer is one of the numbers in the list. We have from negative infinity, we have this number, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and they are going to positive infinity. What else? When we have word between, it means we have to include both ends of range. To find out how many integers we have between 1 and 30, you can always write this 1, 2, 3 until 30 and count them. But we have method to solve this problem in very easy way. When we have integer, let me write this formula, m is less or equal n, the number of integers I such that m is less than or equal I is less than equal n, is n minus m plus 1. So in our case, our n is 30. Our m is 1. From the largest number, we have to subtract the smallest. So we have 30 minus 1, and we need to add 1 plus 1. So this is equal, of course, 30. This is our answer. We have given pair 2 to 31. To find how many integers are there, we have to first know what it means integers. Integer is one of the numbers in the list. Let me write this. From negative infinity, we have this number, negative 3, negative 2, negative 1, 0, 1, and all natural numbers. This is our integers. When we have word between, it means we have to include both ends of the range. And to find how many integers we have between 2 and 31, we can always list these all numbers and count, but we have very easy way. We will just use formula when we have integers m less than or equals n, then the number of integers we just count by using the formula. From the largest number, we have to subtract the smaller, and we have to always add 1. Why we add 1? Because both ends we have to include. So now our m is equal to, in this example, and n is 31. So number of integers between 2 and 31 will be equal 31 minus 2 plus 1. So this is equal 31 plus 1 is 32 minus 2 is 30. So this is my solution. We know that integer is one of the numbers in the list. Let me put this. We have this number from negative infinity, negative 2, negative 1, 0, 1, 2, 3. So to find out how many integers we have between 16 and 82, we can list them all and then count, but it will be too long way. We can use formula when we have integers m less than or equals n. The number of integers between m and n will be n minus m plus 1. Why we add 1? Because we have to include both ends. So now we have to from 82 subtract 16 because our m is equal 16 and our n is equal 82 and we need to add 1. So this is equal. We can always use calculator. 82 minus 16 plus 1, so we have minus 15 is equal 67. This is my solution. We have to find how many integers we have between -7 and 5. When we have word between, it means we have to include both ends of the range. Next, we have to know what it means, the word integers. Integers are numbers like -7, -6, -5, -4, 3, 2, -1, 0, 1, 2, and so on. From negative infinity to positive infinity. To find out how many integers there are between -7 and 5, we can always write these numbers and then count them. But we have easier way, we have formula. When we have integers between m and m is less than or equal n, to count these integers, we use formula. From the largest number, we subtract the smallest, and we have to add 1. Why we add 1? Because we have to include both ends. So, in our case, m is equal -7, n is equal 5. So, we have 5 minus, and m is equal -7, so we have to put this in parentheses, plus 1. So we have 5, negative and negative give us positive, plus 1. So this is equal 13. This is my solution. We have to find how many integers we have between 0 and 50. The word between, it means we have to include both ends of the range. And next, what it means integers. Integers are all natural number and 0 we have to include 1, 2, 3, and we're going to positive infinity. And we have -1, -2, -3, and so on. We are going to negative infinity. So from negative to positive infinity. And now to find how many integers we have between 0 and 50, you can always write this all numbers and count them, but we have easier way. We just use formula when we have to find how many integers we have between m and n, and m is less than or equal n, so we have to subtract from the largest number the smallest, and we have to add 1. We add 1 because we have to include both ends. So in our case, we have that m is equal 0, n is equal 50. So number of our integers will be 50 minus 0 plus 1. So this is equal 51. This is my solution. We have to find how many integers we have between -20 and -2. First, what word integers means? Is one of the numbers in the list from negative infinity. We have -3, -2, -1, 0, 1, 2, 3, and so on. So when we have to find all integers and we have word between, it means we have to include both ends of the range. We can always list all these numbers and count them, but we have formula. So we will use this formula when we have to find all integers between m and n, and m is less than or equals n, then to find all these integers between m and n, we have to subtract from the largest number, smaller number, and we have to add 1. Why we add 1? Because we have to include both n's. So in our case, m is equal -20, n is -2. So we have n minus m plus 1 formula. So this is equal -2 minus -20, because m is -20, so we have to put this in parentheses, and we have plus 1. So this is equal -2, negative and negative give me positive plus 1. So this is equal 19. This is my solution. We have to find how many integers we have between -10 to power 20 and 10 to power 20. So first, what it means integers? Integers are whole numbers including 0 and negative values. So we have this number from negative infinity, -3, -2, -1, 0, 1, 2, and this number going to positive infinity. We have to find these integers between these two numbers. The word between means that we have to include both ends of the range. So next step, it will be very difficult to write these whole numbers because we have 10 to power 20. So we will use formula that when we have pair of numbers m and n, where m is less than or equals n, then the number of integers is equal n minus m plus 1. We have to add 1 because we have to include both ends. So in our example, n is equal 10 to power 20. m is equal negative sign we have, and we have 10 to power 20. So now we will just use this formula. We have n minus m plus 1. So this is equal, n is 10 to power 20, and we have minus, in parentheses we will put negative 10 to power 20. So now we have to add 1. So this is equal, negative and negative give me positive. So we have 10 to power 20 plus 10 to power 20 plus 1. So this is equal, we can write 2 times 10 to power 20 plus 1. This is my solution. We know that integers are whole numbers including 0 and negative values. So let me write this. We have whole numbers from negative infinity, -4, -3, -2, -1, 0, 1, 2, and we are going to positive infinity. To find how many integers we have, it will be very difficult to write these numbers and then count them. The easiest way is use now the formula. When we have integers m and n, and m is less than or equal n, then the number of integers is equal n minus m plus 1. We have to add 1 because we have to include both ends. So now we have in our example that n is equal 10 to power 40, m is equal 10 to power 39. So we have, let me copy our formula, n minus m plus 1 is equal 10 to power 40 minus 10 to power 39 plus 1. We can rewrite 10 to power 4, but this is 10 to power 39 times 10 to first power. When we have the same base, we add exponent. 39 plus 1 is 4, the same what we have at the beginning. And we have minus 10 to power 39 plus 1. So this is equal. We can factorize 10 to power 39 because we have the same expression. So we have 10 to power 39 before parentheses, and in parentheses we have 10 to first power, so this is 10, and we have minus 1, and at the end we have plus 1, so this is equal. 10 minus 1 is 9, so we have 9 times 10 to power 39, and we have to add 1. This is my solution. We have to find how many 4-digit numbers we have. We know that the smaller 4-digit number is 1000. So let me put that our m is equal 1000, and the larger 4-digit number is 9000. Let me write this, 9999. Now we will use formula that from the largest number we have to subtract the smaller number and we have to add 1. This is formula to find how many numbers we have between n and m. We have to add 1 because we need to include both ends. So this is equal, n is equal 9999 minus m is 1000, and we have to add 1. So this is equal, it will be 9000 minus 1000, so will be 8999 plus 1, so this is equal 9000. This is my solution. We have to find how many 5-digit numbers are that end in 1. So first, 5-digit numbers start from 10,000 and the last 5-digit number is 99,999. So we have to find how many 5-digit numbers are there that end in 1. So first number that end in 1 is 10,001. Next will be 10,011. Next will be 10,021. Next will be 10,031. Next, 10,041, and so on. We see that they are multiples of 10. So we can use form when we have number m less than or equal n, then the number of multiples of k is equal. We have to take the floor of n over k minus floor of m minus 1 over k. So in our example, our n is equal, the last digits, 5 digit is 99,999. The m is the first 5-digit number is 10,000. And in our example, k is equal 10. So we have floor of 99,999 over k is 10 minus floor of 10,000 minus 1 over 10. So this is equal 99,999 divided by 10. So we have floor of 9,999.9 minus floor of, and we will have 10,000 minus 1 is 9,999 divided by 10. So this is equal 999.9. And now we have to take the floor of these numbers. Let me remind you, what is the floor of number? Floor of number, it means that we have to find the largest integer less than or equal to this number. When we have 9,999.9, let me draw number line. We have number 0, and now we have 9,999.9. Next integer after this number will be 10,000. And integer which is before this number will be 9,999. So when we have to find the floor of number, so it means we have to find the largest integer which is less than or equal to this number. So the largest integer that is less we have to take in because we have 0.9. So the largest integer which is less than this number is 9,999. So this is equal 9,999. And next number, let me draw another number line. We have 0 and we have 999.9. This number is between 1,000 and on the left side we will have 900. When we have to find the floor of number, it means we have to find the largest integer. What is means integer? This is whole numbers including 0 and negative values. So the whole number will be 999 because this is the largest integer which is less than 999.9. So we have minus 999. So this is equal 9,000. This is my solution. We have to find how many 6-digit numbers end in 0. So let me remind you, the first 6-digit number is 100,000 and the last 6-digit number, this was the first and the last, will be 999,999. So we have to find how many 6-digit numbers we have between 100,000 and 999,999. So how many these numbers between these two numbers end in 0? So first number which end in 0 will be 100,000. Next will be 100,010. Next will be 100,020, 100,030, 1000, 30, and so on. So we see that they are multiples of 10. So we can use formula to find how many multiples of k between m and n, where m is less than or equals m, the floor of n over k minus floor of m minus 1 over k. This is the formula to find how many multiples of k is between m and n. In our case, we have multiples of 10, so k is equal 10. Our m is equal 100,000 and our n is equal 999,999. So let me plug these numbers now to this form. So we have floor of n is equal 999,999 over 10 we have minus, and now we have m is equal 100,000 minus 1 over 10. So this is equal, we divide by 10, so it means we have to move to the left. So it will be 99,999.9 minus 100,000 minus 1, it will be 99,999 divided by 10, so it means we have to move 1 to the left, so it will be floor of 9,999.9 we have. And let me remind you, when we have these brackets, it means we have to find the floor of number. The floor of number, it means we have to find the largest integer less than or equal to this number. Because we have 0.9, it means the largest integer which is less than this number will be 99,999. So this is equal. We have 99,999 and we have minus, again we have floor of this number. So we have to find the largest integer which is less than or equal to this number. The largest integer will be 9,999. So this is equal 90,000. This is my solution. We have to find how many 4-digit numbers are multiples of 10. First, we have to find the first and the last 4-digit number. The first 4-digit number is 1000. And the last is 9,999. So we have first number. We know that we have to find multiples of 10. So we will use formula that the number of multiples of k between m and n number, we have m is less than or equal m, is floor of n over k minus m minus 1 over k. We have to find the floor of the second expression too. So in our example, k is equal 10 because we have to find multiples of 10. M is equal 1000 and n is 9999. So now we have to plug to this formula. We have floor of 9999 over 10 minus floor of, we have 1000 minus 1 over 10. So this is equal. When we divide by 10, it means we have to move to the left side. So it will be floor of 999.9 we have, minus 1000 minus 1 is 999 divided by 10, so it will be 99.9. And now when we have to find the floor of number, it means we have to find the largest integer less than or equal to this number, because we have point here. So the largest integer will be, for the first number, 999. And minus floor of 99.9 will be 99. Why? Let me draw the number line and remind you one more time. We have 0. We know that integers are whole numbers, including 0 and negative values. So let me put that we have here 99.9. This number is between integers 99 and 100. When we have floor of number, we have to find the largest integer which is less than or equal. So the last integer will be 99. So we have 99. So this is equal 900. This is my solution. We have to find the value. First number is 19 over 65 between these brackets. This bracket means we have to find the floor of this number. When we have to find the floor of number, it means we have to find the largest integer less than or equal to this number. We know what is integers. Integers are whole numbers, including 0 and negative values. So let me draw number line. We have in first expression 19 over 65. So this number is between 0 and 1. This fraction, it will be closer to 0 than to 1. 19 over 65. We see that this fraction is between 0 and 1. 0 and 1, they are integers. And now we have to find the integer, largest integer, which is less in this example because we have fraction. So we have to find the largest integer which is less than this fraction. So the largest integer will be 0. So this is equal 0. In the second example, we have negative 7.3. We have to find the floor of negative 7.3. So let me draw next number line. We have 0 and negative 7.3 is on the left side of 0. Let me put this here. Negative 7.3. And when we have to find the floor of number, it means we have to find the largest integer less than or equal of this number. So let's put integer which are less than negative 7.3. So this is negative 8. And on the right side we have negative 7. Number negative 7.3 is between negative 8 and negative 7. And now when we have floor of number, it means we have to find the largest integer, which is less than, is -8. So this is equal -8. This is my solution. We have to find the value. In first example, we have floor of -9. This bracket means we have to find floor of this number. When we have to find floor of a number, it means we have to find the largest integer less than or equal to this number. Because -9 is integer, so the answer will be the same number, -9. Because integers are all whole numbers, including 0 and negative values. So -9 is integer, so the answer will be the same number. In the next example, we have floor of 127. In this example, we have floor of integer because 127 is integer. It means the floor of integer will be the same number. So we have to just copy this number. This is my solution. In this example, we have to find the value of ceiling of this number. In the first expression, we have 0.698. So let me remind, when we have brackets like this, we have to find the ceiling of this number. The ceiling of number is the smallest integer that is at least as big as this number. Because this number isn't integer, because we know that integers are the whole numbers, including 0 and negative values. So first we will draw number line. This number is between 0 and 1. We have 0.698. Because this number is not integer, so the smallest integer will be 1. So this is my solution. And now, in the second example, we have 3 times ceiling of 2.2 plus ceiling of pi. So for this example, we will draw again number line. You have to find 2.2, 0, and put this number here. We have 2.2. Because 2.2 is not integer, because integers are the whole numbers, including 0 and negative values. So 2.2 is between 2 and 3. So the smallest integer for this number will be 3. So we have to copy this 3. We have times 3. We can put in parentheses, and we have plus ceiling of pi. Pi is equal 3.14 approximately. So this is between 3 and 4. Pi will be approximately here. Because pi is not integer, because it's 3.14, and we know that integers are whole numbers, including 0 and negative values. So the smallest integer, at least as big as pi, is 4. So we have plus 4. So this is equal, 3 times 3 is 9, plus 4 is 13. This is my solutions. We have to find the value. On the first expression first, we have ceiling of square root of 5 minus floor of square root of 5. Let me remind you that the ceiling of the x is the smallest integer that is at least as big as x, and the floor of x is the largest integer less than or equal to x. So let me draw number line. We have square root of 5. Square root of 5 is approximately equal to 2.236. We can write, so this number is not integer because integer is a whole number including 0 and negative value. So this number is between 2 and 3. Let me put 2. 3. This number is closer to 2. 2.236 we have. And now in first expression we have to find the ceiling of square root of 5. It means we have to find the smallest integer that is at least as big as square root of 5. The smallest integer will be 3. So we have 3 minus, and now we have floor of square root of 5. When we have to find the floor of number, it means we have to find the largest integer less than or equal to this number. The largest integer, because this number 2.23 is not integer, so we have to find the largest integer which is less than this number. The largest integer which is less we have on the left side is 2. So we have 3 minus 2 is equal 1. We have solution for the first expression, and to the second we have to draw one more number line. We have negative 27.43. This is not integer. And we have to find in first expression, we have brackets like this. It means we have to find ceiling of this number. So we have to find the smallest integer that is at least as big as this number. So let me find this number on number line. We have negative number, so it will be on the left side of 0. This is negative 27.43. This number is between integers negative 28 and negative 27. So first we have to find ceiling of this number. Ceiling, it means we have to find the smallest integer that is at least as big as this number. So the smallest integer will be negative 27, is on the right side. Always when we have find to ceiling is on the right side of this number. So this is negative 27. And now we have minus, and we have floor of the same number. When we have find to floor of number, we have to find the largest integer less than or equal to this number. When we have to find the largest integer less, it means we have to find integer which is on the left side of our number. And this is negative 28. So this is equal negative 27 plus 28 is equal 1. This is my solution. We have to find how many even integers are there between the following pairs of numbers. First, we know that an integer is even if it's twice some integer. So it will be numbers like negative 6, negative 4, negative 2, 0, 2, 4, 6, and this number going from negative infinity to positive infinity. There are even integers. And now to find how many even integers we have between 1 and 40, we can always list them and count them, but we have formula. Because these numbers are multiples of 2, so we will use formula that when we have integers m is less than or equals n, number of multiples of k between m and n is floor of n over k minus floor of m minus 1 over k. In our first example, we have that m is equal 1, n is equal 40, k is 2. So we have this is equal. We have floor of 40 over 2 minus floor of 1 minus 1 over 2. We know that the floor of number is the largest integer, less than or equal to this number. So we have floor of 40 over 2 is 20 minus floor of will be 1 minus 1 is 0. So we have floor of 0. We have floor of integers. So floor of integers is equal to these integers. So we have 20 minus 0, so this is equal 20. This is solution to the first example. Next, this was first and the second. In the second example, we have given integers between -8 and 100. We have to find even integers between -8 and 100. So in this example, we will use the same formula, and now m is equal -8, n is equal 100, and we have even integers. So k is equal 2. So we have floor of n over k, so we have 100 over 2 minus floor of m is -8 minus 1 over 2. So this is equal floor of 50. 100 over 2 is 50 minus floor of -8, -1 is -9 over 2 is -4.5. So this is equal. Now let me remind you, the floor of number is the integer less than or equal to this number. First we have floor of integer, so it will be the same integer 50, and next we have floor of -4.5. This is not integer, so we have to find integer that is largest integer less than this number. So we can always draw number line. We have -4.5. This number is between integers -5 and -4. And now we have to choose the largest integer less than this number. So it will be -5. So we have minus, and in parentheses we will put -5. Negative and negative is positive, so we have 50 plus 5 is 55. This is solution to the second example. We have to find how many even integers are there between the following pairs of numbers. When we have word betweens, it means we have to include both ends of the range. And what else? An integer is even if it's twice some integer. So we know that the integers are whole numbers including 0 and negative values. So even integer will be -4, -2, 0, 2, 4, 6. We're going to positive infinity from negative infinity. And now we see that this number are multiples of 2. So we will use formula that the number of multiples of k between m and n is floor of n over k minus floor of m minus 1 over k. In this first example, let me put this first. Second, for the first example, our n is equal 101, m is 31, and k is 2. So this is equal floor of 101 over 2 minus floor of 31 minus 1 over 2. So this is equal floor of 101 divided by 2 is 50.5 minus floor of 31 minus 1 is 30 divided by 2 is 15. So now let me remind you what is the floor of number. The floor of number is the largest integer less than or equal to x. Because we have 15.5, this number is between 50 and 51. This is our 50.5. So the largest integer less than we have to find because this number is not integer. So the largest integer that is less is on the left side on this number, and this is 15. So we have 50 minus, and in the second expression we have floor of integer. 15 is integer, so it's the same number, minus 15. So this is equal 35. So we have solution to the first example, and to the second we have n equals -85, m is equal -200, k is equal 2. So we will use again the same formula. We have to find floor of -85 divided by 2 minus floor of -200 minus 1 over 2. So this is equal. We have floor of 85 divided by 2 will be 42.5, and negative sign we copy, minus, and we have floor of -200 minus 1 will be -201 divided by 2 is equal 100.5. Now we have to find the floor of these numbers. These numbers are not integers, and we know that the floor of number is the largest integer less than or equal to this number. So we have to find the largest integer that is less than these numbers. You can always draw number line and find between which integers is this first number. So we have -42.5 is between -43 and -42. So the largest integer which is less than this number is -43. we have minus, and now we have floor of course I forgot we have negative sign here, because we have negative number divided by positive. So we have negative 100.5. This number is between integers negative 101 and 100. So we see that the largest integer that is less than this number is negative 101. So this is equal negative 43. Negative and negative give me positive, will be 101. So this is equal 58. This is my solution. We have to find how many multiples of 7 are there between the following pairs of numbers. First, we know that the number of multiples of k between m and n, we use formula that this is equal, number of multiples is floor of n over k minus floor of m minus 1 over k. K is number of multiples, and we know that m is less than or equal n. In first example, this is second, our n is equal 90, m is equal 1, and k, we have multiples of 7, so is equal 7. So the number of multiples of 7 will be floor of 90 over 7 minus floor of 1 minus 1 over 7. So this is equal, first we have to find 90 over 7. This is 12 point approximately 85. And we have minus floor of 0 over 7 is 0. Floor of 0 we have. So this is equal. Next, let me remind you what it means floor of number. Floor of number is the largest integer, less than or equal to this number. Because 12.85 is not integer, so we will draw number line. We have number 12.85. So this number is between 12 and 13. And the largest integer less than this number is 12. It's always the largest integer that is less than number is on the left side of this number. So this is 12. Minus floor of 0, because 0 is integer, is the same number, so we have 0. So this is equal 12. In the second example, we have given that n is equal 48, m is equal negative 7, and k again is equal 7. So we have floor of n over k, we still use this formula. N over k, so it's 48 over 7 minus floor of negative 7 minus 1 over 7. So this is equal. We have floor of 48 divided by 7 is approximately 6.85. And we have minus negative 7, negative 1 is negative 8 divided by 7 is approximately 1.14 we can write. Of course, negative sign. Because negative divided by positive is negative. So this is equal. Now we have to find again floor of these numbers. So let me draw the number line. When we have to find the floor is always on the left side of number. So we have first 6.85. This number is between integers 6 and 7. And the largest integer less than this number is 6. And we have minus. And next we have negative 1.14. This number is between negative 2 and negative 1. Integers, negative 2 and negative 1. So the largest integer that is less than negative 1.14 is negative 2. So this is equal 6 plus 2 is 8. This is my solution. We have to find how many multiples of 4 are between the following pairs of numbers. So we will use formula when we have to find multiples of k between m and n, and m is less than or equal n, k is positive integer. So we have formula floor of n over k minus floor of m minus 1 over k. This is our first example and second. So in the first example, our m is equal 0, n is equal 200, k is equal 4. So we have to use this formula. We have floor of n over k, so we have 200 over 4 minus floor of 0 minus 1 over 4. So this is equal floor of 200 divided by 4 is 50, and we have minus floor of will be negative 1 over 4 is negative 0.25. So now we have to find floor of these numbers. When we have to find the floor, it means we have to find the largest integer. The largest integer less than or equal to this number. Because we have in the first example floor of 50, 50 is integer, so it will be the same number. Floor of 50 is 50, and next we have minus. We have negative 0.25. This number is between, let me draw this, we have number negative 0.25. This is between negative 1 and 0. So the largest integer less than this number is negative 1. So this is equal 51. So this is solution to first example, and to the second example we have given that m is equal 9, n is equal 1698, and we have to find multiples of 4. So we will use again the same formula. We have to find floor of n over k. So we have 1698 over 4 minus floor of 9 minus 1 over 4. So this is equal 1698 divided by 4. This is equal 424.5 minus, and 9 minus 1 is 8. 8 divided by 4 is 2. So we have floor of 2. First number, we have 424.5. This number is between let me write this 424.5 is between 424 and 425. When we have to find the floor of number, it means we have to find the largest integer less than or equal to this number. Because this number is not integer, so the largest integer which is less than this number is 424. It's always on the left side of our given number. And we have minus, and now we have floor of 2. 2 is integer, so it will be the same number, 2. So this is equal 422. This is my solution. We have to find how many multiples of 10 are there between the following pairs of numbers. We have 10 to 6 power and 10 to 8 power in the first example, and in the second we have negative 700 and 4800. So first let me remind you formula when we have to find the number of multiples of k between m and n, and m is less than or equal n, then the number of multiples is equal to floor of n over k minus floor of m minus 1 over k. So this is equal. In first example, we have given n is equal 10 to 8 power, m is equal 10 to 6 power. And we have to find how many multiples of 10. So k is equal 10. So we have to use this formula. We have floor of 10 to power 8 over 10 minus floor of 10 to power 6 minus 1 over 10. So this is equal. We have floor of 10 to power 8 over 10 is like to first power, so we have the same base. We will subtract exponents, so it will be 10 to power 7. And we have minus. We have 10 to 6 power is 1 million minus 1. It will be 999,999 over 10. In first expression, we have floor of 10 to 7. 10 to 7 is integer, so floor of integer is integer, the same integer, so we have 10 to power 7 minus, and when we divide by 10, we have to move to the left side one time only, because we have only 1 0. So we have floor of 99,999.9. And now this is equal. We have 10 to power 7 minus floor of this number. This is not integer, so we have to find the largest integer less than this number. You can always draw number line and find first this number. Let me put this 99,999.9, and this number is between 99,999 and between 100,000. So the largest integer less than this number is 99,999. So we have minus 99,999. So this is equal 9,900,001. This is my solution to the first example. And to the second, now we have that n is equal 4,800 and m is equal negative 700. K, number of multiples of 10 we have to find. So k is equal 10. And now again we will use the same formula. We have floor of 4,800 divided by 10 minus floor of negative 700 minus 1 over 10. So this is equal floor of 480 minus, we have negative 701 divided by 10 is negative 7.1. So this is equal, we have first floor of integer, 480 is integer, so it will be the same number, 480. And we have minus. Now you can always draw number line if you can't find between which integers is this number. We have negative 7.1 is between negative 71 and negative 70. So the largest integer less than this number is negative 71. So this is equal 480, negative and negative give me plus 71. So this is equal 551. This is my solution. We have to find example of numbers x and y for which floor of x plus floor of y is less than floor of x plus y. So let's put that x is equal 4.6 and y is equal 5.7, and we will check if for these numbers this inequality is true. So we have floor of x, so is floor of 4.6 plus floor of y, y is 5 plus 7, is less than floor of 4.6 plus 5.7. So we have floor of 4.6. Let me remind you, when we have floor of number, it means we have to find the largest integer less than or equal to these numbers. So let me draw number line. We have 4.6. Next we have to find between which integers is this number, is between 4 and 5. And now when we have to find the floor, we are looking always to the left side. On the left side, the first integer is 4. This is the largest integer less than this number. So we have floor of 4.6 is equal 4, and we have plus floor of 5.7. We have 5.7. 5.7 is between 5 and 6. And again, when we have floor, we always look to the left side of our number. And for 5.7, the first integer on the left side is 5. One more time. When we have to find the floor, it means we have to find the largest integer less than our given number or equal to this number, because 5.7 is not integer. So the largest integer which is less than this number is 5. So we have that floor of 5.7 is 5, and this is less than, And we have floor of 4.6 plus 5.7. This is equal 10.3. So on the left side, 4 plus 5 is 9. This should be less than floor of 10. Let me draw another number line. We have 10.3. 10.3 is not integer because integers are whole numbers, including 0 and negative values. So now we have to find between which integers we have 10 and 3. This is between 10.3. So this is between 10 and 11. And now when we have to find floor of number, we always look to the left side and the largest integer less than our given number. So this is 10. And we see that 9 is less than 10. Our inequality is true. So our example of x and y is correct. This is my solution. In this example, we have to find numbers x and y for which floor of x plus floor of y is equal floor of x plus y. Let me put that x is equal negative 7.2 and y is equal negative 8.9. Let's now check what we will have. We have to substitute x and y to our equation. We have floor of negative 7.2 plus floor of negative 8.9 must be equal to floor of negative 7.2 plus negative 8.9. Floor of negative 7.2 first we have to find. Let me remind you, when we have to find floor of number, it means we have to find the largest integer less than or equal to this number. Because negative 7.2 is not integer, so we can always draw the graph, can draw number line, and we will have to find negative 7.2 is between which integers? Is between negative 8 and negative 7. So now when we have to find floor of number, we have to look always to the left side. On the left side, the largest integer is negative 8. So the floor of negative 7.2 is negative 8. We have plus. And now we have negative 8.9. Negative 8.9 is between integers negative 9 and negative 8. Again, when we have to find the floor, we look to the left side of our number. On the left side, the largest integer is negative 9. So we have negative 9. And this should be equal to floor of negative 7.2 plus negative 8.9. This is equal negative 16.1. So we have negative 8 plus negative 9 is negative 17, should be equal. And we have floor of negative 16.1 because this number is not integers, so we have to find between which integers is negative 16.1. Is between negative 17 and negative 16. And now when we have to find the floor of this number, we have to look to the left side, and the largest integer is negative 17. So this is equal negative 17. Left side is equal to the right side. It means our example of x and y is correct. This is my solution. We have to show that floor of x plus floor of y is less than or equals floor of x plus y. So first, from definition, we know that floor of x is less than or equals x, and floor of y is the same, less than or equals y. Why? Because when we have to find the floor of number, is the largest, always integer, less than or equal to this number. In first example, we have floor of x, so it will be less than or equals x, and in the second, I put for number y. So we have floor of y is less than or equals y. So now we can add this side, both sides, and we have that floor of x plus floor of y is less than or equals x plus y. What else? Floor of x plus floor of y is integer. And from definition, we also know that floor of x, for definition of floor, we have floor of x plus y is less than or equals x plus y. I just use only definition here. So we see that floor of x plus floor of y is less than or equals floor of x plus y. This is my solution. We have to find how many 4-digit numbers are multiple of your age. So let me first write our 4-digit numbers. First 4-digit number is 1000. And the last is 9999. Next, if k is my age, to find the number of multiples of k between m and n is floor of n over k minus floor of m minus 1 over k. In our example, n is equal 9999 and m is equal 1000. Now we will plug these values to formula. So we have floor of n is 9999 over k minus we have floor of m is 1000 minus 1 over k. So this is equal floor of 9999 over k minus floor of 1000 minus 1 is 999 over k. Now, if my age is equal, for example, 39, so this is equal, now we have to substitute k by 39, we have floor of 9999 divided by 39 minus floor of 999 over 39. So this is equal floor of 9999 divided by 39 is approximately 256.36 And floor of 999 divided by 39 is approximately 25.61. So this is equal. From definition of floor, we know that floor of number is the largest integer less than or equal to this number. Because this number is not integer, so the largest integer that is less than this number is 256 minus, and again the largest integer that is less than this number is 25. We have to always look to the left side of this number. On the left side will be the largest integer, which is less than this number. So this is equal 231. This is my solution. We have given universal set U and sets A, B, C, D. We have to determine the set A plus B, or the sum of sets A and B, or in some books have that we have the union of two sets A and B. What is the union of two sets A and B? Elements which belongs to A or to B. So let me write this. This is all elements X such that X belongs to set A or X belongs to set B. So the union of set A and set B will be the sum of set A, so it means all these elements from set A and all elements from set B. And the elements which repeat, like 3, we don't copy, we just write 1 times 3. So the sum or the union of sets A and B is all elements from set A. So we have 1, 3, 5, 7, 9, 11, 13, 15, and we have to add elements from set B, which we don't have here. So we don't have 2. Next 3 we have, so we don't have to copy. 5 we have, 7 we have, and 15 we have. So this is our union of two sets A and B. This is my solution. We have given universal set U and sets A, B, C, D. In this example, we have to determine the set. We have here this symbol. It means we have to find the product of these two sets, or in some books it is the intersection of two sets. In this example, we have A and B. First, what is the intersection of two sets A and B? Is the set of all elements which belongs to both A and B. So we can write the definition first. It is all elements X such that X belongs to A and X belongs to B. In other words, we have to check which elements repeat in set A and B. The intersection will be sets A and B will be all elements which repeat in set A and B, which elements are the same. So we have intersection of A and B sets is, let's check what we have. We have 1 in set A, and in set B we don't have 1. We have 3, and we have 3 in set B, so will be 3. Next we have 5 and 5, so we have to put 5. We have 7 and 7, and we have 15. 15 repeats in both sets. So this is our intersection of sets A and B. In other words, it is our product of sets A and B. This is my solution. We have given universal set U, and we have given sets A, B, C, D. In this example, we have to determine the set A minus B, or we can read that this is relative complement of set B with respect to set A. In different book, we can read that it is the difference of A and B. We will read that this is A minus B, or the difference of A and B is the set of elements which belong to A but which do not belong to B. So we can write that this is all x's such that x belongs to set A and x is not belong to set B. So now we have to look in set A and in set B, and we have to choose all elements which belong to set A and which do not belong to set B. So let's write this again. We have A minus B is equal, and let's see, we have 1 in the set A and we don't have 1 in set B, so 1 will be in our difference of set A and B. Next we have 3. 3 we have in set B, so we cannot put 3 here. Next we have 5. 5 is in set B, so again we cannot put 5. 7, so we cannot put 7. And next we have 9. We don't have 9 in set B, so we have 9. Next we have 11. We don't have 11 in set B, so we have next element of set A minus B. Next we have 13. 13 we don't have in set B, so this is our 13. And we have 15. 15 is in set B, so it is not in our difference of A and B. So this is my solution. We have given universal set U and sets A, B, C, D. In this example, we have to determine the difference of C and D. Or in other words, we have to find the relative complement of set D with respect to set C. We simply say that we have to find the difference of set C and D. Let me remind you the definition. The difference of set C and D is the set of elements which belong to C but which do not belong to D. So this is equal all x such that x belongs to C and x is not belong to D. So we have definition. Now we have to look in set C and in set D. we have to find all elements which belong to set C and not belong to set D. So the difference of C and D is in set C we have 2 and we have 2 in set D. So we cannot put 2. Next we have 3 and we don't have 3 in set D. So we have 3. Next we have 6 and we don't have 6 in set D. So we have next element. And we have 16 and we don't have 16 in set D. So we have 16. This is our difference of C and D. This is my solution. We have here universal set U. We have sets A, B, C, D, and we have to determine the set. We have in parentheses the union of set A and B, and we have intersection of complement of C. So first, let me remind you the definition of union of two sets. When we have union of sets A and B, so this is OX such that X belongs to A or X belongs to B or to both. So we can find the union of these two sets. Union of A and B will be, let's see what we have. We have to copy all elements from A set and all elements from B set, and we have to put only 1 times the elements which are the same. So we have 1. Next we have 2, 3. We have to put only 1 time. Next is 5, 7, 9, 11, 13, and 15 we have. So we have the union, or in some books we have the sum. They tell we have to find the sum of these two sets. Next we have to find complement of C. So let me remind you the definition of complement of C. This is all X which belong to universal set U and X does not belong to C, set C. So we have to choose all elements which are in universal set and which are not in set C. So we have complement of C as in set C we have 2, 3, 6, 16. So we have to put to complement of C 1 because 1 is not in set C. Next we have 2, so 2 we don't put. 3 we have here, so we will not copy 3 because 3 we have in set C. Next we have 6, 6 we have in set U, so we don't put, and next we have only 16, so the rest elements we have to copy. So we have 1, 4, 5, 6 we will not put, next is 7, 8, 9, 10, 11, 12, 13, 14 of course, and 15 we have. So we have to put all elements which we have in universal set U and we don't have in set C. So now when we have a union of set A and set B and we have complement of set C, we have to find the intersection of these two sets. This is our first set and this is our second set. We have intersection of these two sets. We know what is the intersection, in other words, the product of two sets is all elements which belong to set the union of A and B and belong to complement of set C. Let me remind you the definition. When we have, for example, two sets E and F, so the intersection of E and F will be all X such that X belongs to E and X belongs to F. So we have to choose all elements which repeat in union of set A and B and in complement of C. So let me copy our set. We have in parentheses the union of A and B and we have intersection with complement of C. So this is equal, like I said, we have to choose all elements which repeat in union of A and B and in complement of C. We have 1, 1 and 1. 2 we don't have, 3 we don't have, and next we have 5, 7, 9, 11, 13 and 15. So now we have to copy these elements. 1, 5, 7, 9, 11, 13 and 15. Let's check. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is our intersection of the union of set A and B and complement of C, set C. This is my solution. We have given universal set U and we have sets A, B, C, D. In this example, we have to determine the symmetric difference of sets B and D. First, what is the symmetric difference? The symmetric difference of sets B and D consists of those elements which belong to B or D but not to both. So let me write this, that this is all elements such that X belongs to B or X belongs to D but not to both. So in other words, we cannot put to symmetric difference those elements which repeats in set B and in set D. So let's check first this. In set B we have 2 and in set D we have 2. So 2 we cannot put. Next we have 3 and we don't have 3 in this, so 3 can be 5 and we don't have 5, so it's okay. Next we have 7 and we don't have 7, and 15 and we don't have 15 in set D. The symmetric difference of sets B and D is we have to copy all elements from set B and all elements from set D, and we cannot put elements which repeat, two repeats, so we cannot put 2. So we have 3, 4, 5, 7, 8, 10, and 15. So this is the symmetric difference of sets B and D. This is my solution. We have given universal set U and sets A, B, C, D. In this example, we have to find how many subsets of D are there. So we know that for given set D, we may speak of the class of all subsets of D, and this class is called the power set of D and will be denoted by P of D. If D is finite, then so is P of D. In fact, the number of elements in P of D is 2 raised to the power of elements of set D. So we can write that the P of D has, in our example, the base is always 2. We have to count how many elements we have in set D. We have 1, 2, 3, 4 elements. So we will have 2 to 4th power is 16 elements. So now let's write these 16 elements. So we will have that P of D is, and in brackets, first we can always put empty set, this is empty set. Next, we have to look at elements of set D. We have 2, so can be 2 is subset of D. 4 is subset of D. 8, 10, and next we can have combination like 2 with 4, 2 with 8, 2 with 10, and we not repeat like 10 and 2, it's the same, or 8 and 2 is the same. Next we can take 4 and 8, we don't have. 4 and 10. Next, we don't have 8 and 10. Now we have 1 element, 2 elements, so now will be 3. So can be 2, 4 and 8, and 2, 8 and 10. Next will be 4, 8, 10, and I forgot about 2. We can have with 4, 8 and 8 and 10, but we don't have combination 2 with 4 and 10, and the last is 4 elements, so O set D. 2, 4, 8, 10. This is all subsets of set D. Let's check if we have 16 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 16 elements. So we found all subsets of set D. This is my solution. We have given set A, and set A has elements which belong to Z plus. It means we have here only positive integers, and N is even. Set B has elements 1, 2, 3, 4, and set C has all elements belong to Z plus. So again we have positive integers, and N is odd. So first, all numbers I use for counting are positive integers. So we can write that Z plus is 1, 2, 3, 4, 5, and so on. Next, we have to, in this example, determine the intersection of sets A and B. So first, let me remind you the definition of intersection of sets A and B. In other words, in some books we have called this the product of sets A and B. So the definition of intersection of sets A and B: the set of elements which belong to both A and B. So we have X such that X belongs to A and X belongs to B. So this is our definition. So first, let me remind you even and odd number. We know that any integer, not a fraction, that can be divided exactly by 2 is even. So we can write that set A has elements 2, 4, 6, 8, 10, and so on. So any integer that can be divided exactly by 2, and in this example we have to choose only positive integers. And the B has elements 1, 2, 3, 4. So let me copy this. We have 1, 2, 3, 4. And we know that intersection of sets A and B is all elements which belong to A and to B. So we have to choose all elements which repeat in set A and in set B. So we have 2 and 2, and we have 4 and 4. So intersection of sets A and B is 2 and 4. So this is my solution. We have given sets A, B, C. Set A has elements which are positive integers. So with Z means we have to choose only positive integers, and N is even. B has elements 1, 2, 3, 4, and C has elements, again, we have all positive integers and odd. In this example, we have to find intersection of sets B and C. So first, let me remind you the definition. The intersection of sets B and C is the set of elements which belong to both B and C. So we can write that this is all elements such that X belongs to B and X belongs to C. So we need only B and C sets. B we have 1, 2, 3, 4, and C we have given that C is all positive integers and odd numbers. We know that any integer that cannot be divided exactly by 2 is odd number. So the odd number we have to choose positive. So C has elements like, and of course we know that all the numbers I use for counting are positive integers. So we will have 1, 3, 5, 7, and so on. Again, any integer that cannot be divided exactly by 2 is odd number, and in this example we have to choose only positive integers. So we have C, let me copy B, has 1, 2, 3, 4. And when we have to find the intersection of B and C, it means we have to find all elements which belong to sets B and C. So we have to copy these elements which repeats in C and B. We have 1 and 1, 3 and 3. So we have that intersection of sets B and C is 1 and 3. This is my solution. We have given sets A, B, C, and we have to determine the union of sets B and C. First, let me remind you the definition of union of sets, of two sets. So when we have, can read this, B plus C is equal all elements X which belong to B or to C. So we have all X's, X such that X belongs to B or X belongs to C, or we can write both. So now we have the union of two sets. We have B as 1, 2, 3, 4. Let me copy this. And we know that set C is all positive integers and odd. We know that any integer that cannot be divided exactly by 2 is an odd number. And in this example, we have to choose only positive integers. So it will be 1, 3, 5, 7, and so on. We know that all the numbers I use for counting are positive integers, and we have to just add that they have to be odd. So next, when we have B and C sets, we have to find the union of these two sets. So is all elements which belong to B or C. And when they are repeat, we have to just copy this one time. So we have B, the union of B and C is, we have 1, next is 2, 3, we just put one time, and next 4, 5, and next we have 7, will be 9, and so on. So this is my solution. We have to put all elements from set B and all elements from set C. And when they are repeat, we have to put them only one time. So this is my solution. We have given sets A, B, and C, and in this example we have to find the symmetric difference of sets B and C. So first let me remind you the definition. The symmetric difference of sets B and C consists of those elements which belong to B or C but not to both. So let me write this, that symmetric difference of sets B and C is all x's such that x belongs to B or x belongs to C but not to both. So next, let me copy set B. We need to have set B 1, 2, 3, 4 has elements, and we need set C. We see that set C is all positive integer. Z plus means positive integers. And we know that all the numbers are used for counting are positive integers. And these numbers must be odd. So we know that any integer that cannot be divided exactly by 2 is odd number. So we need to have positive integer and odd. So it will be 1, 3, 5, 7, 9, 11, and so on. So now when we have to find symmetric difference of the sets B and C, we have to put all numbers from set B and from set C, and we cannot put numbers which repeat. So we have 1 and 1, so we cannot put. Next we have 3 and 3, 2 and 4, we don't have it in set C. So the symmetric difference of sets B and C will be, we have 2, 4, 5, 7, 9, 11, and so on. So this is my solution. We have given sets A, B, C, and we have to find which of the following sets, and we have symmetric difference of sets A and C and symmetric difference of sets A and B are infinite. So first let's find the symmetric difference of those sets. We know that the symmetric difference of two sets A and C, for example, consist of those elements which belong to A or C but not to both. So let me write this, that symmetric difference of A and B is all elements such that X belongs to A or X belongs to B but not to both. So first let's find the symmetric difference. Of course, we have here positive. First, let's find the symmetric difference of A and B sets. We need set A and set B. Set A has all positive integers and even numbers. So we know that all the numbers I use for counting are positive integers, and any integer that can be divided exactly by 2 is even. So we have that set A has elements 2, 4, 6, 8, 10, and so on. And B has elements 1, 2, 3, 4. Now, the symmetric difference of sets A and B will be, we have to choose all elements which belong to set A or B but not to both. And we see that 2 repeats in A and B, so we can cross, and 4 repeats. Whatever left belong to our symmetric difference. So we have 1, 3, 6, 8, 10, next will be 12, 14, and so on. So we see that the symmetric difference of sets A and B is infinite, because these numbers go to infinity. We have 14, next will be 16, 18, and so on. So the symmetric difference of sets A and B is an infinite set. And next we have to find the symmetric difference of sets A and C. We have A and we need C. We know that C has all positive integers and odd. So we know that any integer that cannot be divided exactly by 2 is odd number. So C has elements 1, 3, 5, 7, 9, 11, and so on. And now, when we have to find symmetric difference of A and C, it will be all elements which belong to A or C but not to both. So again, let's see, to C and A, we see that we don't have 1 in set A, 3 we don't have, 5 we don't have, 7. So we see that these elements are different. So we can copy all these elements. So we have 1, 2, 3, 4, 5, 6, 7, 9, 8 of course, 9, 10, 11, and so on. we see that we have here all positive integers. So we can write that this is all positive integers. And we see that this set is going to infinity. So our set is infinity.